would see. They're not computer creations, they're actually digital pictures that you can actually see.
The crystal clear images taken by Hubble are some of the most extraordinary visions of space ever seen. The remains of exploding stars streaming through space. Vast clouds of gas and dust where new stars are being born. Distant galaxies spiraling in giant disks and colliding to create supergalaxies.
My favorite image, I think, must be the butterfly nebulae. It's a nebulae that has gas streaming out at 600,000 miles an hour. Telescopes are time machines. We're seeing photons that actually started their journey 13 billion years ago and have taken that long to traverse interstellar space to us. And so you're not only looking out into space, you're looking back in time.
In 1995, Hubble's ability to look back in time is put to the test. Astronomers decide to turn its gaze onto one dark point in the universe, just to find out what they can see.
We picked one tiny point in the sky in which there was essentially nothing there or nothing special there. We stared for 10 days at a single dark spot in the sky.
It is as if Hubble is peering through a tiny keyhole of our Milky Way galaxy to the universe beyond.
The size of the spot that we looked at was no more than drinking straws.
What Hubble sees is extraordinary.
And what we saw were 10,000 galaxies in that single spot. Every point of light that you see in the image represents a galaxy with 100 billion stars like the sun.
Hello.
The image is called the Hubble Deep Field. It shows light from galaxies 4 billion times fainter than anything we can see with the human eye. Light that set out on its journey billions of years ago.
If there is something that gives you a sense of the size of the universe and its depth, it's this kind of image.
Every time the Hubble Space Telescope has been serviced by astronauts, the camera has been upgraded. After NASA's final mission in 2009, a new deep field image reveals the furthest galaxies ever seen, only 600 million years after the Big Bang.
We're seeing back as far as we can see, because we're seeing back to the time of the birth of galaxies.
The Hubble Space Telescope is taking images that continue to amaze us.
And I believe that the Hubble Space Telescope, in some sense, has been really unique in the history of science. It has taken really the excitement of discovery and has made it, to belong to every home, to humans all across the globe.
Hubble has revealed the mysteries of our cosmos in stunning glory. Now, it is working within a vast network of modern super telescopes to investigate a discovery that has rocked the world of astronomy. A discovery that threatens to turn everything we thought we knew about the universe on its head. An enigmatic force called dark energy.
Dark energy is the most mysterious thing we've ever discovered.
It's an energy that seems to be created out of nothing, out of the vacuum. But we have no idea what it is.
Dark energy's discovery comes as a complete surprise. In the mid-1990s, on Mauna Kea, Hawaii at the Keck Observatory, a team of astronomers, including Alex Filipenko, is scouring the distant cosmos. the universe has been expanding. But will it really expand forever? They have a theory. The universe might actually stop expanding and start slowing down.
Just like when I throw this apple in the air, the gravitational attraction of the Earth on the apple slows it down and eventually stops it and reverses its motion. So too, all the galaxies pulling on each other could slow down and ultimately stop the expansion of the universe, to be followed then by the collapse of the universe into a big crunch.
So is the universe really beginning to fall back in on itself? To measure the speed of the very edges of space, astronomers need the most powerful telescopes on Earth. The giant mirrors of the Keck telescopes are 33 feet in diameter, made not from one single disc of glass, but 36 hexagonal mirrors working together. They give a single image of exceptional clarity.
The Keck telescopes are really fantastic devices. They can allow us to see galaxies that are literally at the visible edge of the universe, 10, 11, 12 billion light years away.
But to find out how far away these distant galaxies actually are, astronomers need a standard candle, a star that will act as a cosmic yardstick. But the Cepheid variable stars that Edwin Hubble used are too faint at the extremities of the cosmos. The astronomers need to hunt for an especially bright kind of star inside the furthest galaxies.
There is good.
The deaths of these stars cause some of the most devastating explosions known to humankind. They are called supernovae.
A supernova is quite literally an exploding star. Now, most stars don't explode at the end of their lives, but a few completely disrupt themselves in a colossal, titanic explosion.
And not just any type of exploding star will do. They're looking for a type of supernova that explodes with a very intense and consistent brightness. A type 1A.
They go off as a gigantic nuclear runaway. They're essentially a gigantic nuclear bomb.
In the most distant galaxies of the universe, they find what they are looking for. Type 1A supernovae.
That looks good. There it is, there it is. Look at that. It's a little bit fuzzy.
Now, they measure the redshift to calculate how fast these distant galaxies are moving away. Finally, in 1998, after years of research, they come to a shocking conclusion. The expansion of the universe isn't slowing down at all. It's speeding up.
Much to our surprise, we found that the universe is expanding faster now than it used to be. So instead of slowing down, it's been speeding up. So it's like the apple goes like that. A completely fantastic conclusion.
A mysterious force that no one can see is defying gravity, pushing the universe apart faster than ever. It is the force astronomers now call dark energy.
There's the possibility that Einstein's gravity is incomplete, that we don't understand gravity. There's a possibility that it could change some of the fundamental laws of physics.
But what dark energy actually is, and what it will do to our universe, remains a mystery to this day.
Dark energy is one of the keys to understanding the fate, the ultimate fate of the universe. Is it going to expand forever?
Will it continue to speed up? Will the speed up speed up? In which case the whole universe gets ripped apart.
The one thing astronomers do know is that dark energy makes up most of the universe.
We discovered since that this dark energy is some 72% of the energy density of our universe, and yet we don't know what it is. I mean, just so that you understand the level of the puzzle, I mean, you know, about 70% of the surface of the Earth is covered with water, right? Imagine